Today is 8th of November 2024. We will shortly talk about how can we make AVL trees and non-AVL trees, and how can we verify them with some algorithms. Okay. First, we should make AVL tree to verify it later if it is AVL tree or not AVL tree. If it's, we will also make one Java file to make and to create AVL tree or non-AVL tree. We will make it with generics. So right now we will use almost integers for the files, but maybe later we can use another files. So there will be data. Data is needed. And there will be tree node left, right is needed. And we will by constructor. This is how tree node looks like. And there is string method. String method is construct with just data. When you present it, when you want to print or out, then you use strings to put it out. And there is public static construct tree method, and there is public static private static make subtree method. If you see, then the construct method will get an argument of list of integers, which will be, we will test it later. There will be list of integers will come. Maybe there will be null, or maybe there will be 10, 5, 20, 3, 7, 15, 25. It is each of the node. We will put each of the node here. Then this method will actually first initialize root with null, but it will make subtree with the integers it input and put zeros together. And it goes to the subroot method, and it will input, it will do a very simple process for null case, except null case. A null case will be index is bigger than the length of the list, or one of the index of the list is bigger than the length of this integer, which means it's nothing. There, it can be exist. So we will return null in this case. Except that we will make new tree node. We will make tree node by new tree node method, which will use this integer, one of the integer list, by this constructor. In this case, how we will make it is, when first case, we will use this case, very simply, we will use this case, 10, 5, 20, 3, 7, 55, 25. This will be go here, and this will be go here. With index 0, it will be put here. Then if you see this, then make subtree, which is by these things. And if in this case, first case 0, 0 will put here, then 1 will be shorter than this one. So it will make another subtree with this and put the 0, then it will be 1. Then it will be make subtree of 1, 3, 5, 7, and it will be 2, 4, 6, 8. before it finishes, it will make another sub tree by make subtree method. Can you understand what kind of process is this? If I very simply speak it,
Yeah.
then this is each of the index of the node. And we said it is node left, which means left of the node will have index of 1, 3, 5, 7, 9. If we use this to make node, this is put here and put here, then what will happen to the number 10? What will happen to number 10? Think about it. Think about it. We will look it up. Then, if this by this process we can make AVL tree or non-AVL tree, or some tree will make some tree. There will be some tree. Let's do it one by one. Good. Tree node. Node is made by integers 0. Node is then node will be 10. And next time there is left node, which is 1, will be 5, and right node will be 20. And then if we put it again, 1, 2, 3. 20.
20?
Yeah, because there's some error, isn't it? I'm giving you problem. Find it where is what is wrong. Find out what is wrong. There will be 3. 1, 2, 3, 4, 5. 3. 3 multiple 1, 2, 3. 3 multiple 2, 6, 7. 1, 2, 3, 4, 5. Let's go ahead. Let's say we made a tree.
Yeah.
Then we should verify it. How can we verify it? In verify the Java, we will make the 3 cases. First 3 cases will be it is AVL, and 2 cases will be not AVL because it is not balanced, or it is not make sense because of difference of height. And there will be a lot of test cases, maybe null, maybe 10, maybe the case we did it. And in this case, the third case, it should be AVL. So we should verify this by AVL. And we will make a for loop from test all the things. We will make 3 node. And if it is not 0, then we will make root as root.construct tree with this test case. By this, we will put every list here to test, make trees, and we will check it by comparing the trees that we made here, and we will put this to test case the Java, which is we will test the case. We will put the root, each of the root here, and we will test it by we can say there is 4 cases. First cases will be if root is null or left and right is null, then it will be AVL. Does it make sense?
Yeah.
And second case will be if root left is not null, then we need to test the left of the root is left of the root is smaller than that. In this case, if it is left of the root is bigger than the node, then it is not AVL. Same with the right. So there is second case, left and right. If it is smaller than left node is bigger than a root node, it will be not AVL. And third case is if
So the Prince explanation is what?
where
For the second and third case?
it is not AVL due to its property. We will return the value. And next case it is if is AVL root the left is not AVL, or is AVL root the right is not AVL, then it will be not AVL due to its property. We use recursive method, so we are checking just once by checking once.
Yeah.
Because if we say there is 3, and we check here that from its property, and by recursive method we check here, then we can also the method will again check here to check if it is AVL. So we can use recursive. So by this property we will check AVL. And the last thing is even it satisfies property which is left value is smaller than root and right will be bigger than root. And if it has same number of root, but the depth can be different. How can we check it? We will check it by we will make another count depth function, which will be put the root node, and we will check. We will sum it up. Count depth root that left and count depth root that right plus 1. So we can check each of the root how much depth is it. We check the depth and we will get the value to here. So if count that depth between left and right is different, we will return the value. It is not AVL. Is there any questions?
So
Yeah.
we have that 9 kinds of test case for the whether it is 3 nodes or not 3 nodes, then what about wrong case 판단? 판단 is
We can decide it by already we made true value. First case is AVL, AVL, AVL. So in the for loop, the expected result will print out together. So in first case, it will be AVL. And by that, we will return some value. So we can check it if the method is correct or not.
first case is that is AVL, and another is that is not AVL because
No, this 5 standard is by this algorithm, we will test one by one. We will put this to here, then there is some AVL tree made like this. By this, we will put 10 to here to test it. If root is null, 10 is not root, no, so it passes it. and root left is not null. Left there is 5 exists, and compared to 5, it is bigger than 0, so it will pass the test. And in this case,
So that if the 10 skip 10 take all the tests, that is AVL.
yeah, you
That's
should
the
make
result.
algorithm here very well. So make that AVL.
Then if the among that process, the 10 is rejected at one,
Then maybe it can, if it satisfies this condition, it will return this value, or
but
this value.
if unsatisfied, then the AVL, not AVL due to observable is printed,
No,
right?
one of these 5 conditions should be print. That's how you should make algorithm. One of 5 conditions would be print. Here will be return value.
Yeah.
And there is answer AVL. So you can compare, you made your algorithm correctly. This is how verification algorithm is working. This algorithm, what I'm confusing right now is how the data is working, and is it really enough by fourth condition to check all the nodes, and how string works, and how make subtree and construct tree algorithm successfully make the trees. I'm curious about this. Did you understand how it's working? Okay. Then next time I will more focus on how test case.java algorithm is successfully recursively working with only checking the rooftop left and rooftop right. And also, we will also discuss more about how T data is working and how toString method is used. And we will also see how construct tree can make successfully trees in a sorted status. Thank you very much.